So we are continuing our discussion regarding the Murray's majority element voting algorithm. So as I told you that in this algorithm we have two parts. Number one is find candidate to the majority element. Find candidate of majority element. And the second step is for check whether this candidate is majority or not, is majority element or not. Okay, now in this video we are going to check out this step-by-step algorithm, which is the find candidate of the majority element, and then we are also going to check the step-by-step algorithm about how this checker algorithm works, which checks whether the candidate is a majority element or not. Now let us look at step by step. Here we have two values, which is array A and the size of the array. For demo purposes, let me just take one example of an array which is having some values. This array is having 4 1 4 0 4 4 4 6 4. Index locations are 0 1 2 3 4 5 6 7 and 8. So how many times 4 is repeating here? A total of 1 2 3 4 5 6. So total of 6 times the element 4 is repeating itself. Okay, now check out here, the total size of this array is actually 9, and this is the array A. So here we are going to pass this array A, which is the array on which we are performing the operation, and here we are passing the size, which is 9. Now the first step is initialize the index and count of majority element. So we have two variables. You can take these two variables as integer variables here. Number one is the majority index, which is maj_index, which is having the value 0, and second is count, which is having the value 1. Actually this maj_index is representing what element we are currently using. And then we are having this loop from here to here. This loop will start from I is equal to 1. So you can see I is equal to 1 to size minus 1. If the value of size is 9, so this loop will run till the value of I will become 8. Okay. Then we are having if A of majority index is equal to A of I, that means the value pointed by majority index is equal to the value pointed by I or not. Okay, then we are going to do count plus plus, else we are going to do count minus minus. After performing these two operations, only one of them will be performed. Then we are going to perform this C operation. So initially you can see the 4 is not equal to 1 because majority index is pointing 4 and second number is 1, which is not equal to 1. So this will not be executed, only this will be executed, which says count minus minus, the value of count will become 0. Okay, now what we are doing is, the next step, if count is 0, then majority index is equal to I. So if count is 0, that means again the count is 0, so we are going to put majority index as 1 because it is equal to I and I is currently pointing to this location, and then count is equal to 1. Again we are going to implement count as 1. After this step again we will go back to the previous case. Okay, now the value of I will become 2, that means I is now pointing to this location. Now you can see here this 4 and 1, they are not equal. The first step, 4 and 1, they are not equal, so we'll execute this else statement which says count minus minus. So we are going to decrement the value of count. Again this condition will be executed, which says if count is equal to 0, then majority index is equal to I, so majority index will become 2, and we are going to make count as 1. So now majority index is pointing to this location. Again go to the loop, so I will point to this location. I is pointing to this location, which is having the value as 0. Now here the value is 0, and this 0 is not equal to the majority index, which is 4. Hence we are going to decrement the value of count, and again we are going to make the majority index value as pointing to this location, which is 3. Okay, next time again the value of 5 will be incremented. Now here we have the value which is 4, and 4 is not equal to 0, this 4 is not equal to 0, hence the count value will become 0, and we are going to decrement the make the majority index value point to 4. Okay, the next step, this value 4 and this 4, they are equal. Okay, every time we are incrementing I because of this loop, right? Just follow the steps performed in this pseudo code. Now this 4 and this 4 is equal, hence we are going to increment the value of count as 2, again increment the value of I. Okay, this 4 and this 4 are equal. Okay, because majority index is pointing to 4. You can see this step is executing from the last 2 times. The same A of majority index is equal to A of I, then just increment the count plus plus. Now because these two 4s are equal, hence the value of count will be 3. Again increment the value of I. Now I is pointing to this 6 and this 4, they are not equal, hence the count will be decremented, but this time the value of count is not 0, therefore this will not be executed. Again increment the value of I. Now we have again 4, therefore we are going to increment the value of count as 3. Now this loop is finished, so next is we are going to return the location of majority index. So the location of majority index is 4. Now you can see because count is not 0, hence we found an element which may be a candidate of the majority element. Therefore because of this index location, we can sign A of majority index might be the majority element because count is greater than 0, right? So this entire pseudocode we have performed step by step. Now the next step is check whether it is a majority element or not. So till now we have implemented find the candidate of the majority. So the next step was to print majority. Next step is if candidate is a majority, that is it appears more than n by 2 times, print the candidate, else print no majority element found. So what we are going to do is, here in the previous case, in the entire array, as you can see in the previous case here, in this entire array we found out that 4 is a majority element. So what we'll do is we'll write a program or pseudocode for this. We can just simply write a pseudocode which says print, let me just write it here, which says print majority, or just check majority. So what we can do is we can take this array as input, we can take the total size of the array, and thirdly we will take the index of the majority element. So index of the majority element is let us say index. Okay, now we can take a loop, we can write a for loop which will start from the first location, this location, till the end, and which will count up the total number of appearances of the majority element. So we'll take a variable which is count, and initially this count variable is having the value 0. So what we are going to do, for I is equal to 0 to size minus 1, for I is equal to 0 to size minus 1, every time we find this majority element, every time we find this majority element, we have to increment the value of count. So let us say we store this index, int majority is equal to A of index. Okay, this is what we can do, A of index. That means we store the value of majority here, and if A of I is equal to majority, then count plus plus. This is a simple for loop, very simple for loop. And then we can say if count is greater than n by 2, hence print candidate of the majority, else print no majority element exists. Okay, this is a very simple step that we can take to print this majority candidate. Okay, now you can see finding the majority element using the Moore's voting algorithm is pretty simple comparatively, and secondly the time and space complexity is very easy. So the time complexity of the Moore's voting algorithm will be order of n to find the candidate of the majority plus order of n to check whether it is a majority element or not. and to print whether this majority element or not. So time complexity will be order of n, and the space complexity of the Moore's voting algorithm will be order of 1 because we are not using any extra space. Don't worry, we'll come to the programs. We'll write the program to for the Moore's voting algorithm also. Now, the next step, let us look at one more solution to solve this problem, and that solution will be by using the hash tables, or you can say hashing. Okay,